AI governance does not end when a model goes live. At enterprise scale, trust depends on continuous monitoring, evidence-based assurance, rapid incident response, and improvement loops that keep AI behavior aligned with risk, compliance, and business goals. You've already explored enterprise AI risks and the foundations for governance, security, compliance, and trust. Now the focus shifts to sustained operations, how to keep AI systems monitored, controlled, and accountable after deployment, before you move into the capstone work. A one-time approval only works if the system stays the same. AI rarely does. After deployment, data can drift, models may be updated, prompts can change, and users may interact with the system in unexpected ways. Regulations, threats, and business expectations also continue to move. Continuous governance creates the feedback loop needed to monitor behavior, collect evidence, test controls, and adjust decisions so the AI remains safe, compliant, and aligned with its intended purpose. Continuous AI governance depends on three operating habits. First, follow the system across its full life cycle, from design and build to deployment, change, and retirement. Second, monitor more than accuracy, including risk, drift, misuse, security, compliance, and real user behavior. Third, prove control with evidence, not promises. Incidents, metrics, audits, and stakeholder feedback then feed improvement, turning governance into a repeatable operating capability. At enterprise scale, governance has to run as a loop. Teams monitor model behavior, data drift, user activity, security events, and compliance signals. They assess whether controls still work and whether risks remain acceptable. If something goes wrong, they respond using incident playbooks. Then they improve prompts, guardrails, datasets, policies, and procedures, so each cycle strengthens the system. Governed AI monitoring is a system, not a single dashboard metric. Uptime tells you whether the service is alive, but not whether it is trustworthy. You need behavior signals such as accuracy, hallucinations, and refusal quality. You need risk signals including toxicity, privacy leakage, and unsafe outputs. Drift detection also matters because inputs, prompts, embeddings, and retrieval sources change over time. Finally, monitor for misuse such as jailbreaks, prompt injection, credential abuse, and agent actions beyond authorized boundaries. Operational governance keeps every production system connected to its inventory record, risk register, model card, controls, monitoring data, and audit evidence. As telemetry changes, automated triggers can prompt reassessment, update risk status, or escalate an incident. Clear ownership is essential. Business, model, security, compliance, legal, risk, and audit teams should all know when they decide, when they review, and when executives need to be informed. An AI operations dashboard turns scattered oversight into a shared operating picture. The goal is not just reporting, it is coordinated action. Performance, drift, bias, security events, incidents, compliance controls, and business impact should be visible together, because these signals affect one another. Different teams may need different views, but they should work from the same source of truth. Strong metrics have thresholds, owners, alerts, and escalation paths. Most importantly, trends over time help small changes surface before they become failures. Model monitoring is no longer one scoreboard. Predictive models need classic performance checks, such as accuracy, errors, and calibration. LMs need behavior checks, including hallucinations, groundedness, toxicity, refusals, and consistency. RAG systems add retrieval quality, source freshness, citation accuracy, and embedding drift. Agents require oversight of tool use, permissions, escalation, and autonomous action risk. The pattern is straightforward. Monitor each AI system according to how it can fail, and preserve evidence for alerts, reviews, and governance. AI incident response begins with signals that normal monitoring may miss: jailbreaks, leakage, biased outputs, unsafe advice, or agent actions. Triage then classifies severity, affected users, regulatory exposure, and business harm. Containment should be fast and practical. Teams may disable tools, restrict retrieval, roll back prompts, freeze model versions, or add human review. After containment, investigate the evidence, remediate the root cause, and feed lessons back into controls, playbooks, and assurance. Trust in AI cannot rely on policy statements alone. Assurance means proving that controls work and that the system stays within its risk boundaries. Evidence may come from monitoring logs, validation results, model cards, data lineage, risk assessments, incidents, and control tests. The key is traceability. A requirement maps to a control, the control produces signals, and those signals support audit findings, regulatory responses, and governance decisions. Governance KPIs turn trust from an aspiration into a management system. They answer 4 questions: how much of the AI portfolio is covered, whether controls are working, how quickly issues are detected and contained, and whether trust outcomes are improving. Useful measures include ownership, risk assessments, failed controls, overdue remediation, incident severity, fairness, explainability, complaints, and audit readiness. The point is not reporting for its own sake. It is a feedback loop that drives accountability and continuous improvement. After deployment, AI governance cannot depend on someone will handle it. Every production system needs named business, technical, risk, and operations owners. Those owners must understand their responsibilities for monitoring, incidents, control fixes, and reassessment. Decision rights also need to be explicit. Who can approve a model change? Who can pause the system? Who can accept a risk or escalate an incident? Regular governance forums then use dashboards and evidence to keep accountability active. The biggest governance failure is treating approval as the finish line. Without monitoring, incident playbooks, KPIs, and clear owners, risks can stay hidden until they become audit or business problems. The thumb rules are simple. Governance continues after deployment, and if you cannot monitor it, you cannot trust it. The key message is simple. AI trust must be operated continuously. Monitor behavior, detect drift, respond to incidents, preserve assurance evidence, and improve controls as conditions change. Next, you'll apply these practices in the readiness capstone, then connect them to transformation strategy and future-ready trust architecture.